In today's video, we will be talking about the genomic analysis of COVID-19 as of April 10th, 2020. For the full situation report and other COVID-19 resources, please visit our website at nextstrain.org. In today's report, we will focus on transmission dynamics between regions of the world, tracing how the outbreak has unfolded month by month. Currently, we have analyzed 3,160 publicly shared SARS-CoV-2 genomes. By comparing these genomes to each other, we can characterize how COVID-19 is moving around the world and spreading locally. The sequences are from samples taken in 57 countries across 6 continents. While this data enables us to infer many useful characteristics of the outbreak and track its spread in real time, it's important to emphasize that our conclusions are limited by the available data. For example, the map shows very few sequences from the global south. This is not because COVID-19 isn't circulating in these areas or that these cases are not as crucial to understand. Rather, we just don't have much data available from these areas. Keep in mind that the size of each circle on the map indicates how much data is currently available from that area, rather than the true size of the outbreak. Before we begin diving deeper into how the outbreak has unfolded, there are some general terms you'll need to know because we'll be using them throughout our report. For example, the tips of the tree represent samples from infected individuals and are colored according to where they were sampled from. For an internal node or a branch point, each represents an unsampled case which was an ancestor of all the other cases within the descendant clade. These are colored by the inferred or most likely location of the ancestral case. And lastly, a clade is a grouping that includes a common ancestor and all the descendants. Here we highlight samples from mid-December 2019 through mid-January 2020, during the first month of the outbreak. Comparing where a sequence was isolated from geographically to where its ancestors were circulating can help us understand not only where infections are occurring, but also where they may have been acquired. The common ancestor of circulating viruses appeared to have emerged in Wuhan, China, in late November or early December 2019. Accordingly, the majority of sampled and inferred ancestral cases were located in Asia during this early period. This is consistent with circulation largely within China and some exported cases to other countries in Asia for the first month of the outbreak. During the second month of the outbreak, from mid-January to mid-February 2020, we start to see individual cases crop up in North America, Europe, and Oceania. These early cases still group with samples from Asia and generally lack the hallmarks of local transmission. This is consistent with initial sparks being thrown from main outbreaks in Asia to other parts of the world. Although most of these sparks did not result in localized outbreaks, at least 3 of these introductions took off. These led to the large European and North American outbreaks, as well as more restricted spread in Oceania. When we zoom in to the top of the tree for the same time period, looking at the internal node, we see an ancestral European virus that seeded the large European outbreak. This indicates that while we haven't yet sequenced any samples from this clade, the origins of the European outbreak were already circulating undetected by January or early February. When we zoom in to the bottom of the tree, looking at the internal node, we see an ancestral North American virus that initiated what would later become a large outbreak in North America. This indicates that although we only had one sequence case from this cluster at the time, the virus was circulating undetected within North America by late January or early February. During the third month of the outbreak, from mid-February to mid-March 2020, these 2 clusters expanded to cause large outbreaks within Europe and North America, respectively. Within each of these regions, we see widespread mixing across state lines and international borders. This is demonstrated here by the intermingling of samples from multiple U.S. states and Canadian provinces. We have also seen similar patterns of frequent mixing between European countries which were mentioned in a previous report. The North American and European clusters are not restricted to their respective regions. During this time period, we also see cases from South America, Oceania, and Africa against a backdrop of primarily European and North American clades. This indicates that there were frequent intercontinental introductions during this time period. Interestingly, samples from the global south span the full breadth of the tree, indicating that these regions' outbreaks are mixtures of many viral lineages. In the last month, the pandemic has come full circle. Here, we see reintroductions from Europe and North America back to Asia. This resoundingly demonstrates that this pandemic is a global fight. We all must help control this virus everywhere if we hope to defeat it anywhere. In conclusion, here are some takeaways from our report. Regional and national outbreaks are and will be deeply intertwined. And this pandemic is a global fight. We all must help control this virus everywhere if we hope to defeat it anywhere. Here are some steps you can take. Practice strict social distancing and reduce the number of people you are in contact with, even if you're not vulnerable. Practice social distancing to protect others. Many people around you are vulnerable, such as seniors and those with pre-existing conditions. Wash your hands like you just chopped a jalapeno and have to change a contact lens. Remember to stay home as much as possible, especially if you're sick. Be prepared with a few extra supplies in case you need to self-quarantine. And if you're an employer, encourage your employees to stay home when they're sick and financially support them to do so. Here are some other steps your officials can take. Some examples are to make testing free and broadly available, to put strong social distancing measures in place, to fund and implement extensive contact tracing and isolation efforts, and lastly, to financially support those impacted by social distancing measures. We would like to acknowledge the amazing and timely work done by all scientists involved in this outbreak. Stay tuned for our future reports as we're in the process of moving to more specific, regionally focused analyses.